Okay, so everyone's talking about the super blue blood moon total lunar eclipse that's happening this week, so I thought I would try to make a video about it using this simulation software. This is software called Stellarium. It's free, anybody can get it, and planetariums and educators use this, so it's pretty good software. To show this event, I picked a very plain landscape with zero horizon because the horizon is going to get in the way of this event. So let's take a look at what it's going to look like. So I'm starting this at about 5:30 in the evening on January 30th. You can see the time and date down here. And the simulation has us located in Knoxville, Tennessee, which is in the Eastern time zone. We're not going to have a very good view of the eclipse here, but let's see what it will look like. So 5:30 this evening, this is what it will look like if you look to the west. The sun's just about to set. And because it's a full moon, I know that because just as the sun is going to set, the moon is going to rise. So let's look around to the east, turn around. This is turning 180 degrees around. And look to the east, and there's the moon just coming up. So if you look to the east, just about 5:30 this evening, or maybe a little bit later if your horizon is not plain like this, you'll be able to see the moon coming up. So let's take a closer look at what the moon looks like. I'm going to select it and zoom in with our telescope, and we'll see what it looks like. This is a full moon. Actually, let me get it a little bit darker here. We'll go forward in time a little. There. Okay. So now we've got the moon at night. This is a full moon, which means that the sun is shining all on the side that we can see. If you could fly around to the back, the back of the moon would be black because the sun's not shining on it. It's called a supermoon because it's at the closest part of its orbit around Earth. It's called perigee. The moon's orbit around the Earth is not a perfect circle, and it's not perfectly centered, so sometimes that's a little closer and sometimes a little farther away. Right now it's a little closer. It's called perigee. When it's a little farther away, it's called apogee. The difference between perigee and apogee is about 26,000 miles, which sounds like a lot, but it's about 10% of the total distance that it is away from the Earth. So really not that much, but it does make a pretty big difference in what it appears to us. It looks about 14% larger when it's that much closer, and it looks about 30% brighter. And because of some optical effects around the way the Earth's atmosphere and horizon works, it looks even bigger than that when it's near the horizon. So if you can see it just as it's coming up or just as it's going down, it's even more impressive. All right, so that's the supermoon part of what's going on tonight. So let's zoom back out. We'll see where this is in the sky right now. See, here's the horizon down here, and the moon is up here. So let me click away from the moon, and we'll look back to the west again. There. So now we're facing west again, and I'm going to take us all the way through the night so we can see what this will look like early in the morning. So you can see time advancing down here. You can see the time going forward. This is 9 o'clock. You'll see some planets and some other stars and familiar constellations going by as we go through the night. This is about midnight. That's the Pleiades star cluster right there. Inside Taurus the Bull, that's Taurus's head right there. Here's Orion. Looks familiar. It's got a couple of very bright stars in it. This is the closest and brightest star that we can see in the northern hemisphere, called Sirius, and there's the moon coming into view. And here's what the sky will look like at about 6 o'clock in the morning on January 31st. So here's the moon, still pretty far above the horizon. So I'm going to advance this forward just a little bit more. We'll go forward to about 6:30. Okay, so there's the moon above the horizon. It's about 6:30, and I'm going to zoom in again, and we'll see what it looks like again. So it looks pretty much the same, still a supermoon, still a full moon. But if you keep watching this, it will start to look a little bit different. I'm going to fast forward time just a little bit, and we'll see what changes. So here's 6:40, 6:50, and you start to see a little reddish shadow coming across the top of the moon by about 7 o'clock. Do you see that? See that reddish shadow? That is the edge of the Earth's shadow. I'm going to stop it right there. Because you see the sky starting to get lighter. That's because the sun's coming up. And you know what happens when the sun comes up during a full moon? When the sun comes up, the moon goes down. So this is pretty much all of the eclipse we're going to be able to see here in Knoxville. Fast forward it, and pretty soon you'll see the moon actually go below the horizon, and it will disappear altogether. See, there's the horizon. So there's the edge. That's the most of the eclipse we're going to be able to see here in Knoxville. And the sky's starting to get light already because the sun's coming up. Okay, so that's about it. We're going to see a little bit of the edge, and then the moon's going to disappear from our view. So not very good eclipse viewing here in Knoxville. However, because we're using a simulator, we can look at this eclipse from anywhere we want to. So let's change our location. And I'm going to pick a city that's very far to the west. Let's go to Seattle. We'll see what this eclipse looks like in Seattle. So when it's 7:30 in the morning here in Knoxville, it's 4:30 in the morning out in Seattle. So you can see that time here. So at 4:30 in the morning, a partial eclipse will be going on. The moon will be partly in the Earth's shadow. So I'm going to advance time a little bit faster here. Okay. So here's what the moon looks like at 4:30 or 5 o'clock in the morning out west, way out west on the west coast. You can see this red shadow is getting further and further over the moon. Now, this is the blood moon. The moon will look kind of red if you're here in this total eclipse zone. Now, the reason it looks red instead of just black is because of something called Rayleigh scattering. And Rayleigh scattering is the same reason that the sky looks blue and sunsets look red. It's because of the way the air in the atmosphere scatters sunlight. So the air in the atmosphere around the Earth is scattering sunlight that's going on the edges of Earth and bending it around, so just the red parts of sunlight are shining on the moon while the moon is in the Earth's shadow. So it's the same reason. What you're seeing is red light from all of the sunrises and sunsets all around the world, bending around and shining on the moon. So by about, here we are at local time, about 6:30 or so, the partial eclipse starts to end in Seattle. And by about 7 o'clock, it will be all done. The peak time for the maximum total eclipse is about 5:30 in the morning. So if you're on the West Coast and you want to see that, 5:30 in the morning is when it will be at its darkest and reddest. And then there's the end of the eclipse by about 7 o'clock in the morning in Seattle. If you want to know exactly when the eclipse or any eclipse is going to happen in your town, look at a website called Time and Date. It has really good local information for all kinds of stuff like this. All right. Thanks for watching. Bye.